Today's topic is gluconeogenesis, or how the body produces energy using non-carbohydrate sources such as amino acids and glycerol from fat. So again, I've defined what gluconeogenesis means, and essentially the body has to have an alternative means of producing energy to fuel the cells when carbohydrate isn't available. So if you're in a starvation state and you've utilized all your glycogen stores, you've catabolized them, the body has to turn to another alternative source of fuel, and that's going to be your lean tissue stores, which of course, let me remind you, involves not only your skeletal tissue but also your organs and your fat stores. What comes to mind, some of these survivor type shows or shows in the wilderness where people are in these adverse climates without food or other means of nutrition, and if you look at them and their metrics before they go to the location and then after when they're finally picked up, it's quite startling. And obviously what's going on is they've exhausted their glycogen stores. They have to attain their own food, and they're not going to the local superette, and they're utilizing their lean skeletal tissue stores and their fat stores. So let's talk about what happens when these two alternate fuel sources are utilized by the body. How do proteins or amino acids enter the pathway? So in order to utilize an amino acid for fuel, the amino group has to first be removed, and ammonia is created, which is a waste product. And that ammonia is converted to urea, which of course is excreted in urine by the kidney. So we excrete that amino group that's been removed ultimately. And these deaminated amino acids, as we call them, enter cellular respiration at various stages in the cycle. And the amino acid chemical properties dictate where in that TCA cycle that they might enter. So which intermediate will they be converted to depends on the actual properties of that amino acid. So let me give you an example to make it a little bit more clear. The amino acid glutamate is converted to alpha-ketoglutarate, and that's where it enters the TCA cycle. So again, depending on the property of that amino acid that's been catabolized or broken down will dictate where in that TCA cycle that it actually enters. It's fairly straightforward. I've got a picture showing you this, a diagram I guess we should call it, and it illustrates where various amino acids based, again, I'll say it a third time, I think I've already said it, where those amino acids enter the cycle depend on the properties of that amino acid. And I'll let you take some time to look at this. In terms of lipid, what are we really talking about? Well, we're talking about triglycerides, which, as I'm sure you'll recall, are composed of a 3-carbon backbone, so that's the glycerol portion, and a fatty acid tail, 3 fatty acid tail. And that glycerol, so the 3-carbon backbone, is converted to glyceraldehyde 3-phosphate, and that's what enters the TCA cycle. If the body wants to break down the fatty acids, that's got to be done via beta oxidation, and that occurs in the matrix of the mitochondria. Just as the TCA cycle occurs in the mitochondria, so does the beta oxidation of fatty acids. And the fatty acids are broken down into 2 carbon units, to which coenzyme A is added, and magic, you get an acetyl-CoA. It's our favorite, right? Acetyl-CoA. We can all work with acetyl-CoA in the TCA cycle. And then, of course, that acetyl-CoA feeds into the TCA cycle that we all know and love. And this is a little sketch, I confess I didn't do it, of what happens when lipid or triglyceride is used in the Krebs cycle, or is broken down so that it can be used in the TCA cycle. You have the glycerol backbone, see the 3 carbons, you have the fatty acid tails, and the glycerol is converted into the glyceraldehyde 3-phosphate. So pretty straightforward. So the next time someone wants to talk to you about a low carbohydrate diet and how fantastic it is, you can kind of go off on them about, you know, how energy is going to have to be utilized to create glucose ultimately from these non-carbohydrate sources. You'll one up them. It'll be a great dinner conversation. Let me know if you have any questions, and I look forward to seeing you next time. Take care. Bye.